Hi class, it's Mr. Trez, and this video is going to be about vertical translations of functions. Our learning objective: the student will be able to write an expression for a given function that has been vertically translated by analyzing the graph. The objective will be met if the student receives a 100% on their Google Slides assignment. Our essential question: if graphs of functions are related by translating up or down, how are the expressions related? Okay, so before we move on to translations, we just want to do a quick review of quadratic functions. So our standard form of the equation would look like y equals ax squared plus bx plus c. Our table of a quadratic function has a constant second difference. And then finally, the graph of a quadratic function has a U-shaped, which is called a parabola. So some important terms. First, in gray, is the parabola. And the parabola is the U-shaped graph of a quadratic function. Next is the y-intercept, right here in blue. And this is the point where the parabola crosses the y-axis. Next, we have our two x-intercepts. This is the point where the parabola crosses the x-axis. These are also called zeros or roots. Next we have is our vertex, which is the maximum highest point or the minimum lowest point of a parabola. It is where the parabola changes direction. So right here in red would be our vertex. And then finally in orange we have our axis of symmetry. This is the vertical line containing the vertex of the parabola. It's the line that cuts the parabola in half. So in this example, our axis of symmetry would be x equals 1. Okay, so what we want to look at in this lesson is what's called a translation. So if I had a translation, I'm just going to draw a parabola right here at U. Okay, translation in math means to move an object. So if I started with a parabola right here, and let's say I wanted to move it 2 units up, I'm literally just going 1, 2. Or if I wanted to move it 2 units down, 1, 2. So we're going to start with like an original parabola, and we're going to translate it vertically, which means it's either going to go up or it's going to go down. Okay, so the diagram shows graphs of two functions. The graphs are related to each other by translating up or down. So in our case right here, we have a parabola in red. So the parabola, the graph is going to be red, and that matches with the red part of our table. So the equation for this graph is f of x equals x squared. So our x-coordinate is -4. Our y-coordinate should be 16. So -4, positive 16 should be a point. I'm just focusing on the red, and I can see right here I have a perfect point. Okay, now remember, it is symmetrical. So point -4, 16, that means we're going to have point positive 4, 16. Next is -3, 9. So I'm starting -3. And I'm focusing right on the red, and I can see I have a perfect point right here on 9. So -3, 9, and then symmetrical, positive 3, 9. -2, 4, same thing, starting at -2, focusing in on the red, gives me positive 4. Symmetrical, again, that would be positive 2, positive 4. So -1, and here I'm just analyzing the graph. So -1, positive 1. And then positive 1, positive 1. I could fill in the table. And there we go. Okay, so now we want to take a look at b of x. So what happened was this red graph translated downward, vertically downward. And how many units did it go down? Well, if we analyze the graph, it went down 1, 2, 3 units down. So let's analyze the graph and complete the table. So b of x, we have -4, +13. So now I'm focusing in on the blue. Got it. Okay, we have a perfect point right here. Since it's symmetrical, +4, +13. Okay, next we have is -3. So let's take a look at -3. I'm just going to find the blue until we get to a perfect point, which is right here, +6. So I'm going to fill in the table with +6. And since it's symmetrical, +3, +6 should be a point. Now, I want you to analyze the table with patterns. So since this graph translated 3 units down, let's see what happened to the points. So it started at the red, and then it went down 3 to the blue. So 16 minus 3 is 13. 9 minus 3 is 6. 4 minus 3 is 1. Since it's symmetrical, we'll put a 1 here. Okay, 1 minus 3 is -2. Since it's symmetrical, -2. And then 0 minus 3 is -3. And we can double check just to make sure. So if I just spot checked and I said, okay, 0, -3, 0, -3, perfect. 1, -1, -2, and then +1, -2. So all the points on our table are correct. So now we want to take a look at the rule. So f of x, which is really x squared, translated to b of x, which has what rule? Well, we have x comma y. So the x coordinates, they didn't change. We still use the same x coordinates right here. So since the x coordinates remain the same, we're going to keep the x coordinate as x. But what happened to the y coordinates when we translated it? So it started at y, and then it went down 3. Started at 9, which is really y, went down 3. Started at 0, translated down 3. So the y coordinate went down 3. And now finally we have our expression. So we want to write an expression for b of x. So what we want to remember is that these two parabolas were related. Okay? So f of x, which is really x squared. So we're going to start our expression with x squared. And then what happened to this x squared? What happened to this red parabola? It went down 3. So the way I'm going to represent that, down 3, x squared minus 3. And here is my equation. Okay, what I'd like you to do is please complete the Google Slides. Make sure that you please do the blue reflection. If you have any questions, please send me an email. Thank you for watching this video.